Welcome to Working in Cx5. This is the first video in the Atom Bean Industries sculpting tutorial series. This video is your complete introduction to the material and techniques I've developed over the past 10 years.
In this video, I'll cover everything you need to know to take a piece from start to finish, using many innovative techniques that are only possible in Cx5. I'll show you a new way to approach sculpting, free from armatures and other traditional restrictions, and how to achieve amazing results using hand building and machining. In short, I'll give you all of the tools you'll need to transform your ideas into complex, finished sculptures. But before we jump in and start making things, I'd like to give you a context in which to understand the techniques you're about to see. That context is the mindset of the professional sculptor. It's a way of thinking that cuts across many disciplines not traditionally thought of as sculpting, but all with one common problem to solve. How do we make a piece that is durable and permanent? As artists, we're all faced with the problem of how to make our work last. A sculpture can only last as long as the material it is made from. There are three ways people have traditionally solved this problem. The first is by sculpting in an already permanent material like stone. But this is a very challenging medium to work in. The second is by sculpting in something soft that becomes permanent, like ceramic. But ceramic sculptures tend to be fragile, and the clay they are made from needs sturdy armatures to support it while sculpting. The third is by sculpting in something non-permanent, like clay, and then using molds to transfer the sculpture into something permanent, like bronze. Bronze is one of the most durable and enduring materials a sculpture can be made of, and therefore it falls into the category of what I call final materials. There are many final materials beside metal. Glass and plastic also fall into this category. This practice of transferring from one impermanent material to a permanent one is the iterative process of professional sculpting. For centuries, sculptors have used this process to create public monuments and fine art, as well as the small things of daily life. Everything you see that is uniquely shaped was created by someone, either by hand or, more recently, with the help of computers. From action figures, ornaments, and Easter bunnies, to bicycle seats and sneakers. The world is full of sculpted forms created in a sculpting material and then cast in something else. For those objects that need a specific quality, like the flexibility of a sneaker sole, or the durability of a hammer, the original sculpture must eventually be cast in the appropriate material. So what exactly is the iterative process of professional sculpting? Traditionally, it has consisted of three materials used one after another to create the final object. I call these the initial, finish, and final materials. Sculptors begin their work in an initial material, usually something soft like water clay or oil clay, to rough out the shape and create the large forms. That piece is then molded using either plaster or rubber in a process called waste molding. The resulting mold is filled with what I call the finish material, usually a wax. Wax is used for the second stage because, unlike most clays, which tend to be too soft to hold fine detail or crisp edges when being handled, wax can be tooled and carved and even melted to create textures, features, and shiny surfaces that stay put. But wax can't be modeled like clay. It is too brittle and crumbly. So it can really only be poured into a mold of an existing sculpture and finished by hand. The next step is molding the finished wax piece to capture all the newly added details. The final material, metal, glass, or plastic, is then poured into this second mold, and that casting becomes the final product. For centuries, this five-step process has been the standard of professional sculpting. Cx5 streamlines this process by completely eliminating the second and third steps. The three different physical states of Cx5 allow for three different kinds of behaviors, making it both a perfect initial and finish material. With Cx5, we can skip beginning our sculptures in a clay, skip the waste mold, and skip transferring the sculpture into a wax, and instead do all our work from start to finish in just the one material.
The iterative process of professional sculpting is the most versatile method for creating practically any shape a human mind can imagine. It is an answer to how we can create objects that endure. And with Cx5, that answer is now simpler. As we dig deeper into what Cx5 can do, remember that whatever you create can be molded and cast and preserved forever.
I want to talk a little bit about setting up a work area. If you already have an area set up for sculpting, that's great. If not, you'll want a place you can make a bit of a mess. It should be clear of papers and other objects. I like to use a table that's about waist high for my initial sculpting. Next, you'll need good light. For big sculptures, I suggest getting overhead studio lights, but for sculptures that can fit on a table, I like to use a simple swing arm lamp, because I can direct the head where I need the light. Also, it has two bulbs, a fluorescent ring, as well as an incandescent bulb, giving a very even, balanced light. Strong light is good for sculpting, because you'll be working in a monochromatic material, where shadows are going to be your guide to the contours of the piece. Next, because some of these hot sculpting techniques involve fire, you'll want to get a fire extinguisher. It's better to have it and not need it, than to need it and not have it. Then, to produce a clean flame, you will need denatured alcohol. This fuel burns with no soot. If you use any other source for flame, you will get soot on your tools, and then you will transfer the soot to your sculptures. So, denatured alcohol only, in your alcohol lamp. This is an inexpensive item. It consists of a closed jar with a wick. Next, the sculpting tools. I actually do a fair amount of sculpting, especially roughing out, with just two tools. You want metal tools that you can heat up. A tool can be anything from a butter knife to a fine handmade minaret. Of course, you'll need some sculpting material. For this video, I will be using Cx5. And finally, we need a way to warm the material up to working temperature. This is simply an inexpensive electric frying pan. They come in different sizes. For large projects, I use a bigger pan because it keeps the material at a steady temperature better. But for demonstrations and small projects, a small pan is fine. You can also warm the material up under a lamp, in a double boiler, or in the microwave. Be careful with the microwave method though, because the inside will heat up before the outside, and you can burn yourself. For those of you wanting to do small-scale intricate work, a waxer is indispensable. There are many kinds of waxers available for the jewelry and dental industries. This is a Kerr Ultra Waxer. I'll go into more detail about the waxer shortly. To supplement the two basic tools I use for roughing sculptures out, I also use a small spatula tool I made. I do 99% of my portrait sculpting with this tool and the waxer. Next up is a small loop tool. I made this one out of a dowel and guitar wire. This isn't absolutely necessary, but it's nice to have when working in small details. For extruding different shapes in Cx5, you can pick up an extruder. This is just a barrel with a plunger and different apertures through which you can push the material. While we're rounding out the toolkit, let's add a chip brush. This is a handy item to have around, especially when working on wrinkly skin textures. When working on large areas, a sharp file is essential for smoothing things out. I also like a small half-round file for smoothing out tight spots. For cleaning out the teeth of the files, pick up a file card. They're cheap and absolutely essential to keep your files from loading up with material. Next, we have an alcohol torch. This is great for smoothing out very small areas, warming spots up to add material, and for fire polishing. Finally, there are the sanding pads. These are made by 3M. They're for sanding things like joint compound when putting up walls, and for sanding Bondo in an auto shop. They hold up well to heat, just don't get them hot enough to create smoke. They are urethane pads covered with a fine abrasive. I can't vouch for the safety of heating them, but I don't think it creates enough of anything to be particularly bad for you. In terms of art materials and processes, this is not high on the list of things to worry about. I do most of my fine detail work sitting down. I have a jeweler's desk. This is, of course, not necessary if you're just starting out, but it's a good idea for the professional sculptor. You can keep supplies handy in the drawers, and the pull-out tray is great to work over, to catch shavings, dropped parts, or tools. The second tray is a convenient place to keep the parts of the sculpture you are working on, and the bench pin is a great place to work on a small piece. To begin with, you'll need to get the material warm. You can do this slowly, for instance using a lamp, and letting the heat penetrate all the way through for a consistent clay-like feel, or quickly with a hot pan or microwave. I like to melt the amount I plan to be working with, and then let it cool to the proper working temperature. It melts at about 155 degrees, but I wouldn't try sculpting with it until it has cooled to about 125. For those of you working in the Celsius scale, that's 52 degrees. This may sound hot, but consider that it's only just a bit warmer than your body temperature. It should be pleasantly warm to the touch, not hot. At this temperature, it will behave like clay, either water-based or oil-based that you may be familiar with. Or if you want it softer, you can just keep it a few degrees warmer. For this demonstration, I will be using a larger pan to keep the material at a more consistent temperature, and I will show you how I begin a sculpture. Because a person's legs are generally half their height, I like to start there. If I know the final height I want the figure to be, I can easily begin my sculpture by rolling out a length of Cx5 that, when bent, makes a loop about half the height of the final figure. I put in rough approximations of feet, and, if I were making the figure a specific height, I would check the length of the legs now. In some cases, as in the Conan O'Brien project, I get lucky, and I find a full-length picture of the subject and can print it out to the proper size. This is a huge time saver on rush projects. Here I am checking the length of the legs. Next, I begin to add mass at the top. As this cools, it will create a very strong foundation for me to continue my way down the legs. While I'm adding material to the hip and thigh area, the rest of the legs are continuing to cool and strengthen. I will not try sculpting the feet until the legs are firm enough to hold their form and position. At this stage, while the material is just above body temperature, it is stiff enough to hold its form, but can easily be positioned. I have decided my figure will be running, so that I might demonstrate the usefulness of being freed from restrictive armatures and supporting boards, which limit the angles from which you can view your work. Now that the legs are roughly positioned, I continue to build upward, creating a base on which I will build the torso. This allows the legs further time to stiffen into position, but as you can see, it is still quite easy to reposition the figure. Before the legs get too cool, it is time to begin adding some musculature. I like to heat the surface of the material in order to ensure good cohesion. This only heats the surface because I am not holding it over the flame long enough for the heat to penetrate the leg, which would make it unstable. As it is, I can now press firmly without fear of deforming the limb. With the lower legs roughed in, I put a mass at the top of the torso to describe the position of the shoulders. I decide to put a dramatic twist in the torso to create a figure who is trying to balance a sudden movement. Perhaps it is a soccer player. Speeding up the tape, you can see that I am moving around the figure, from the torso to the legs, giving each section time to firm up enough to allow me to easily handle it and add more material without distorting the underlying structure. Now I add the upper arms and begin to define some of the anatomical features of the torso. Once the upper arm is cooled enough, I can add the lower arm. I'm not worrying about anatomy right now. I am more concentrating on getting the overall attitude of the figure roughed in. Once the arms are in place, I add the neck, and then the head. At this point, I heat up my spatula tool and begin defining shapes with it. I'm not concerned with a knowledge of anatomy so much as a keen observation of contours. I will address that subject in depth in my video on figure sculpting. It is time to evaluate the figure overall. Now is a good time to make any large adjustments to the pose. Although it is quite easy to warm the figure up again later and reposition it, I try to get as much of the pose locked in now as possible. By rewarming areas, it is possible to use a loop tool or rake to begin to define the anatomy. I never stay on one area for long. Because of the nature of the material, I don't have to worry about handling the figure, so I am constantly turning it around, observing it from all angles, so no one area gets too far ahead of the rest. Now I use my sanding pad. I heat it up just a little over the flame, and if the sculpture is warm, I can easily smooth out large areas with it. This helps to visually unify the piece, making it easier to evaluate the pose. I am 45 minutes into the sculpture, and even now it is easy to reposition the figure. At the 1 hour mark, I decide to evaluate the figure again. I will put the sculpture down for a bit and come back to it with fresh eyes. When I do, I see that the torso is a bit short. This is easily corrected. I simply cut it in half and add more material in the midsection. I heat my knife and work my way around the figure. At last the halves come free. Again, I heat the surfaces to ensure good cohesion. Now that the figure is back together, I am able to evaluate its height and even give it more twist than it had before. In just 10 minutes, I have added height to the midsection. Evidence of the alteration quickly disappears. At any time, I can completely change the position of the figure. Here, I have cut it in half again, and am using a heat gun to warm the material slowly. I warm the material up with the heat gun, but just until the surface is shiny. Any longer and it would begin to drip. Then, I wait for the heat to radiate from the surface throughout the piece. I do this process several more times until the piece is warmed all the way through. Now it is easy to bend. This process is particularly useful if the figure has to be sculpted to fit with another, as was the case in the Conan O'Brien project. I had to make many adjustments, not only to get the proper regal pose, but also to make sure he sat naturally on the swan. To my knowledge, no one has ever sat astride a live swan, but being able to sculpt the two characters separately helped me to make it seem natural. And being able to warm them up again helped me to get them to fit together. Stitching pieces back together after they have been cut is another indispensable technique. This allows me to work on bits of the sculpture that would be nearly impossible to reach if they were still attached. I call it stitching because that's what it reminds me of, the needle of a sewing machine repeatedly piercing the cloth. Importantly, I don't just melt each side over a flame and then smush them together. If I were to do that, I would lose the position of the pieces relative to each other. Instead, I align them and make one small stitch to hold their positions. Then I slowly move around the piece, gaining confidence as each stitch cools. If all has gone well, the pieces will be in the exact same position they were in before they were cut or broken from each other. I will have lost no material, and I don't run the risk of accidentally shortening a limb. Here I have cut the arm off the Conan sculpture in order to work on the hand that will be holding the reins. And here I am working on the portrait. Another benefit of this is that it's easier for my hands to warm the piece to the point where I can push the material around. This is particularly useful for small details like eyelids and lips. Some textures can be pressed in at this point, like pores in the skin. For deeper textures, I either use the waxer on a low setting or I scrape them in with a sharp tool. To demonstrate, I have an arm that I have cast up from a previous project, which required multiple demon hands to be grabbing a character. To accomplish this, I made a rough sculpture of one hand and cast it multiple times in Cx5. Then, warming each casting up, I repositioned them. To cast them, I warm up the mold with a heat gun, and when it is warm to the touch, I pour in the melted Cx5. The fingers do not cast all the way, but that is easily remedied. I use some of the material from the vents I have cut beneath the fingers to rebuild the fingertips. To create a deeply wrinkled texture, I run a sharp scraping tool over the surface in erratic, crisscrossing lines. Though skin on an arm would never wrinkle this way in real life, I would like to mention here that it is important to always look at reference when creating skin texture. Observe your own hands. Wherever skin has to bend in multiple ways, it will have crisscrossing lines in it. For this demonstration, I will create a deep texture on the forearm. This is where a chip brush can come in handy, as the process can create a lot of small shavings. I am satisfied with the texture so far and would leave it rough like this if I wanted a tough, cracked elephant skin effect. But I decide to give the wrinkles a smoother appearance, so I use a solvent to soften the hard edges. In this case, I am using a small stiff brush dipped in naphtha. This is the lighter fluid one uses to refill Zippo-style lighters that have wicks. Be careful though, the naphtha can soak in deeper than you want, creating a mushy surface. To prevent this, I wipe the surface frequently, seeing how much material the process has removed. It is easy to go too far. This is the final result, wrinkles that look soft and weathered. I often use solvent to smooth out areas after I am certain I have gone as far as I can with tools and hot sanding. For instance, to get clothing looking velvety smooth, I use a sanding pad dipped in naphtha, as here on the Conan O'Brien jacket. A word about naphtha. It is an organic solvent, like rubbing alcohol or gasoline. These are not particularly good things to have on your skin. There are other solvents out there that will work, but they tend to stay on the surface, making it gummy. Naphtha evaporates quickly, and used in small quantities, it is relatively safe. The more detail you put in your sculptures, the more time it is likely spent in your hands. Sculptures can get dirty just from repeated handling. Surface discoloration on a dirty sculpture can act like camouflage, making it difficult to judge the true shape of the piece. Obviously, the first thing you can do to keep your sculptures clean is wash your hands frequently. I like to powder them as well with ordinary baby powder. But if your sculpture is looking dirty, you can simply wash it. I use ordinary dish soap, water, and a toothbrush. Be sure not to use dish soap that contains bleach or a bleach alternative, as this can affect the surface, making it appear chalky. Simply get the sculpture wet, apply the soap, and scrub. You don't have to worry about losing detail. You won't. You now know enough to create a sculpture of a person, from roughing out the figure and evaluating the pose, to repositioning it and creating skin textures, even how to keep your work clean. But what if you want to create something that is not an organic shape? Perhaps you wish to sculpt parts for a concept car, or a model of a handheld device. I would like to head away from the figurative world and introduce you to the awesome possibilities of hand building. To begin with, I will show you how to extrude Cx5 to create long tubes that can be used for veins, wrinkles in clothing, and so on. I often use this technique when I have to sculpt laces on shoes and boots. The easiest way is to begin by rolling out a tube of Cx5 that will fit inside the barrel of the extruder. I want a close fit because air pockets can ruin an extrusion. You can also block the aperture and fill the tube with liquid Cx5 and wait for it to get to the proper temperature to extrude. This method avoids possibly trapping air bubbles. But for small aperture extrusions, rolling out a tube works fine. Importantly, the extruder is made completely of metal, so it is easy to heat up and it retains its heat for a long time. I heat the tube and then let the heat radiate throughout the material inside. A steady push gives a long extrusion. I like to coil it like rope for later use. Bending the cooled extrusion is as simple as warming it in your hand and shaping it for whatever is needed. If you have cold hands, you can warm them first in the pan of Cx5. This is also great for cold days. Large extrusions can be rolled to straightness if you need a rod of material. We will come back to this for the section on machining. For sculptures that require smaller diameters, I like to use wire. This technique requires some finer control over the waxer, so now I would like to talk a little more about that tool. Waxers come in all shapes and sizes. Some are simply a box with a rudimentary soldering iron type end. Others, such as mine, have digital controls and an LED readout. But I want to point out that the numbers on the LED readout don't necessarily correspond to the temperature of the tip. The machine has no way to gauge its own temperature, no feedback circuit, and so it simply puts out a voltage the manufacturers thought would get the tip to the temperature on the LED screen. Here, I am using a sensitive thermocouple to find out if the temperature of the tip is what the readout says. The result is that it runs low. The result would be even lower were I using a larger tip, because the same voltage would be even less able to heat a larger mass. So regardless of what waxer you have or what temperature it says it is, I can tell you the actual working temperature of the material is about 300 degrees Fahrenheit for general waxer use. For coating wire, this is a good temperature. To demonstrate, I will quickly create a small sculpture out of wire. This particular wire I'm using is called magnet wire. It is for winding electromagnets. You can get it at your local electronics store. You don't have to use this, however. Any wire will work. I like to use this because it is so thin. I decide to sculpt an insect, because this is the most difficult thing I can think of to sculpt with any other method. I cut 3 lengths of wire and twist them together. When I fold this on itself, it creates the 6 legs I need. Using the waxer, I am able to quickly cover the wire. I carefully coat each leg, and then the center loop. With a pair of pliers, I can bend the wire to create the sections of the legs, even though it is already covered with material. Then I begin to add material to sculpt the legs. To get finer detail in the legs, I would turn the temperature of the waxer down. As it is, I am able to easily define the contours of the legs. The wire loop covered in Cx5 makes a nice thorax. I add a pinch of material to this to form the abdomen. In just minutes, the insect is taking shape. Because it is looking like a thread wasp, I decide to give it a longer abdomen. This is a simple process. First, I split it with the waxer. Then, I add another length of wire. Finally, I rejoin the pieces. As I lower the temperature of the waxer by about 50 degrees Fahrenheit, I am able to do something astonishing with the material. By blowing on it as I move the waxer away from the piece, I am cooling the material everywhere but at the surface of the tip, where it remains liquid. I call this pulling threads. This is a great way to make small sharp spikes, hairs, and even antennae. But blowing on the piece has more mundane and useful applications as well. I often like to move a large amount of material fast with the waxer and have it stay where I want. I make extensive use of this technique when I am sculpting portraits. In my recent portrait of Steve Jobs, I made use of both techniques. Especially prominent are the glasses made of Cx5 coated wire. It's great to be able to create forms this way, and simply tack them together instantly, and then build onto them. Wire isn't the only thing that can be used as an understructure for building delicate forms. I do a similar thing with paper. Some projects require complex hollow shapes, like an eggshell or a box, that could be painstakingly sculpted by hand, but might not wind up with a uniform wall thickness. Hollow shapes are easily built out of Cx5 coated paper. To coat paper, I turn the pan up to where the material has just melted. A larger pan would allow full sheets, but these can be difficult to manage. I suggest starting off with small sheets until you get the hang of the technique. Different papers give different results. The best, in my experience, has been rice paper, because it has an open, porous surface. Writing paper is too tightly grained to allow the Cx5 to soak in. The drawback to rice paper is that it can leave a bumpy result that needs to be sanded down. This is because of the fibers of the paper sticking up. But it is not difficult to sand down afterward, so I will use it for this demonstration. Dipping both sides in the liquid material, I ensure that it has soaked and penetrated for maximum adhesion. I scrape the excess off on the edge of the pan. With practice, it is possible to leave a thin layer on each side. The pieces cool quickly. It is easy now to cut them with an X-Acto knife. Using these very thin sheets, I will show you how I create a small box-like form. If I were trying to make something specific, I would draw on the surface with a soft pencil before cutting. But just cutting at random, I create a shape that looks as though it might become a model of a handheld device. Then, with the waxer, I can tack the pieces together. I can use the heat of my hand to soften the vertical piece as I go. This is a great way to achieve smooth curves and transitions. To create sharp bends, I use the waxer to heat the Cx5 coated paper in just one spot. It bends easily. Adding a top to the box is as easy as tracing the outline of the box with a waxer and then trimming off the excess. If I wanted a sturdier piece, I would simply coat 2 pieces of paper and mate them with a final dip in the liquid Cx5, giving twice the thickness. As it is, this is surprisingly sturdy for such thin walls. A similar method can be used to create flowing fabric, like capes. For the Conan O'Brien project, I used this to create the Finnish flag he was to be carrying. For this, I dip fabric in the Cx5, and after it cools, I am able to cut the pattern. Cx5 dipped cloth cuts cleanly and easily. If I wanted to shape clothes for a figure, I could cut an actual clothing pattern out of the sheet, as a tailor would out of cloth. A soft pencil can be used to draw the pattern on the material. In this case, I am drawing the cross on the flag for later reference. It would be far too difficult to draw it on after I bent the piece into the flowing fabric shape. Heating it up with a heat gun is a great way to get it malleable over and over, as many times as you need in order to get the result you are looking for. A waving flag would be very difficult to sculpt using any traditional method, but as you can see, in just seconds I can create a very convincing shape. Dipping paper and cloth in liquid Cx5 are both great ways to achieve interesting shapes. And while the material is in its liquid state, I would like to introduce a third. Cx5 can be brushed on. This is great for creating large sculptures or anything that needs to be lightweight. Just a thin layer of Cx5 over foam makes a surprisingly durable piece that can be finished in a variety of ways. I will demonstrate how one can achieve smooth, lightweight forms for models. Here I have cut a simple shape out of foam. Perhaps it will be a model of a bullet train or a side view mirror. Any ordinary soft paintbrush will work for brushing Cx5 on. For very large forms, like a car bumper, a heat gun is helpful to promote adhesion between layers, as well as to smooth out the work as you go. This process can be scaled up to any size. It is a great way to create industrial design models, sculptures for concept car parts, or futuristic body armor type sculptures. When the material cools a bit, I can easily scrape it with the loop tool to refine the shape. Repeating the process can yield smoother, more precise results. An initial round of hot sanding smooths out the piece, but won't help me get rid of subtle dips and bumps. To achieve a perfect contour, I use a file, and, this time instead of solvent sanding, I will use wet sanding to smooth out the form. Both solvent sanding and wet sanding are great ways to smooth out your work. For large objects, I prefer wet sanding, both because it is faster than solvent sanding and because it does not involve potentially harmful chemicals. Unlike the solvent in solvent sanding, which dissolves part of the sculpture, the water in wet sanding is there simply to rinse particulate out of the grid of the sandpaper, to keep it from loading up. Using just water and 120 grit sandpaper, I am able to sand the surface smooth in just minutes. Cx5 can be brushed on to virtually any material: foam, wood, plastic, even oil-based clay. By brushing it onto other materials, it is possible to quickly create complex models incorporating existing forms. Here, I have brushed Cx5 onto a model of a Dodge Viper. And, using some of the existing forms as a guide, I have completely rethought the front end, the hood, the roof, and the rear window, using a repetition of the curved shape I liked from the door. Using hot sanding, filing, and solvent sanding, I am able to produce a smooth, clean surface quickly. I primed the car with gray primer before I brushed the Cx5 on, so that I might work with an object that is all nearly uniform gray. But once I begin filing and sanding, the white plastic pokes through again, so it is helpful that I can prime it again for a clean finish. Also, like paint, Cx5 sticks better to primed plastic than it does to unprimed plastic. Using the techniques you have just seen, extruding, wire coating, paper building, cloth forming, and foam construction, you can make a neat, clean model of almost anything, and do it at virtually any size. But there are some shapes human hands simply can't make. For those, I would like to introduce you to the world of machining. For millennia, people have employed simple machines to help them create shapes that bare hands alone cannot make. Today, machines are used to create complex shapes in hard materials like wood, plastic, and metal. Beginning with materials in basic forms like sheets, boards, blocks, and rods, it is possible to build the intricate shapes you see around you in your daily life. For this section on machining, I will be starting with hard Cx5 that has been cast into a variety of simple shapes. Then, using machines, I will modify them to form more complex shapes that can be joined together using some of the techniques I covered in hand building. The easiest way to create any base shape is to cast it. Cx5 casts nicely in simple plastic forms. These were cast in the disposable containers from consumer products and in do-it-yourself Christmas ornaments from a craft store. Cx5 releases easily from many surfaces. Here, I am pouring it onto a cookie sheet. When the Cx5 hardens, it can be used like a sheet of plastic that might be drilled, cut, sawed, or bent. As with paper building, you can use flat pieces to construct a shape, but this way, the two flat sides need no sanding. And here, I am pouring the liquid material into a short length of plastic pipe. The metal surface cools the material quickly, so I don't have to worry about it leaking out the bottom. Using found or bought pipes, cans, or bottles, I can create plugs or rods of any diameter that can then be turned on the lathe. It releases easily. Using just these cast forms, I am going to create a model of something that I could not sculpt by hand. Note that this model will be built from just one material, using no glue. This is remarkable in the world of prototyping. I begin on the lathe, turning the rod as though it were plastic. A jeweler might use this and drill a hole down the length of it and cut a section off to form the band of a ring, but I have something more complex in mind. Because Cx5 is temperature sensitive, I use a medium speed and a medium feed for most machining operations. Water can be used as a cutting fluid. Air also can help to keep the parts cool and free of chips and shavings. If your feed is too fast, the machine will produce chips, which can leave a rough surface on the part. A good speed produces shavings that can of course be collected and melted down again. Without using air or water, I still get a nice smooth cut and a clean finish. This can be buffed while still on the lathe. Also, if I have made a mistake, perhaps cutting one too many rings, I can simply use the waxer to fill it back in. And then use the lathe to recut the area flat. In any other material, I would have to start over. Of course, if I completely mess it up somehow, I can remelt and re-pour the piece in about half an hour. In just minutes, I have a shape I like. It looks a bit like a model for a microphone, or the beginning of a prop for a science fiction movie. Next, I add to it something cut from the flat sheet. I draw my pattern first, using basic tools like circle guides and French curves. I am not making anything specific, just using circles and curves to create an interesting base shape, which I may add onto later. Then I use the drill press to cut the holes. I do this before cutting out the shape so that it is easier to hold and work with. This method of widening a hole on the drill press is safe only for Cx5. Don't try this with harder materials like wood or metal. Using a jeweler's saw, I connect the two holes to create a slot. This would be easier and cleaner on the milling machine, but I want to show how the material works with hand tools. For cutting thin sheets of any material, one generally wants a fine saw blade with many teeth, and if you saw slowly, this will work well. But many teeth create heat, and that can make the Cx5 stick to the blade. I prefer a medium blade to prevent the Cx5 from loading up in the teeth of the saw. Moving too quickly will also melt the material, and it can refuse in the kerf behind the blade. When sawing sheets of Cx5, go slowly and patiently. I filed the cuts straight. Another method for making cuts is to use a sharp scraping tool. Multiple passes separate the pieces. I mark my next cuts to form a step that will lay flush against the part I turned on the lathe. I tack it in place with the waxer and check to make sure it is straight and true. Then I carefully mate the pieces with the waxer on a low setting in order to minimize disturbing the crisp, perfect surfaces. A light sanding tidies up the work. Another good way to adhere shapes to each other and keep their interface clean is to melt through them. Here I add a button. Using my waxer, I melt down to the mating surfaces. This allows me to bond them without trying to fit the waxer tip between the smooth forms, which would ruin the perfect surfaces. Now they are fused, and I can file the button flat. To give the model flat sections, I will use a milling machine. A milling machine is useful for creating rectilinear forms. It uses a spinning tool called an end mill, which is like a drill bit, but without the pointed end. The part is clamped in a vise and moved back and forth or up and down against the end mill. In its most basic mode of operation, it can cut channels and steps into the material. The options for different end mills and milling operations are too numerous to mention here. For my model, I have decided to cut flats around the circumference of the stock. Here, I am using a piece of equipment called a dividing head. I can index the head to any angle and then run the end mill across the piece to create as many flats as I choose. I have divided the piece into sevenths, giving 7 flats. Using these machines, some hand tools, and these joining techniques, I can make a perfect model of just about anything. Now, if you don't own or don't have access to such machinery, I can show you a simple way to at least try your hand at turning. Using a hand drill and 2 quick clamps, it is possible to construct a simple lathe. The first clamp holds the drill to the bench. And the second clamp acts as a variable speed on-off switch. I closed the chuck gently on a short length of Cx5 rod that I rolled out in the section on hand building. Using just a few simple tools, I am able to quickly create a small, detailed turning. With care and sharp tools, I can create any turned shapes I like. I decide to create a lightsaber because this is a familiar object that many sculptors in the action figure industry tried to create with hand sculpting alone. Nothing can compare to the crispness of machined parts. A dab of Cx5 left round and then flattened makes a nice dial. Another quickly becomes a rectangular button. Using the smallest extrusions I made in the hand building section, I can easily add the fins seen on many Star Wars props. If I were trying to recreate an actual prop, I would be measuring everything, but here I am just having fun freehanding some technical looking features. The waxer on a low setting easily creates holes that would be difficult to machine. Two more drops of Cx5 become round buttons. I could spend quite a bit more time on this, adding and making details crisp and perfect, but in just 45 minutes I already have a very passable lightsaber, made using nothing more than the basic tools and a drill. This is faster than it can be created on a computer, and the results are cleaner and crisper than even today's 3D printers can make. Of course you could devote a lifetime to learning all the techniques of machining, but with just these and some Cx5, you should be able to make just about any mechanical looking object you can think of. You now know the basics of casting your base shapes and modifying them by scoring, drilling, sawing, turning, milling, and joining. By breaking objects down into their constituent shapes and building up to fully realized complex shapes, you should be able to create very clean models and prototypes of just about anything in Cx5.
This has been Working in Cx5, the first video in the Atom Bean Industries sculpting tutorial series. The tools and techniques you've learned about today are all you need to bring your ideas into reality.
We've covered the principles of professional sculpting, setting up a clean and safe place to work, and how to rough out a full figure. Building up a form without an armature, hot sculpting, hot sanding, repositioning, and joining will help you create any dynamic pose you can imagine. We've also looked at the intricate work that can be done with a waxer, as well as the unique possibilities with paper building, cloth forming, and painting Cx5 onto objects. Combining these techniques with machining operations like milling and turning will give you the freedom to create any piece, from the most organic to the most mechanically complex.
So have fun, be careful around hot tools and materials, and start sculpting right away. I can't wait to see what you create in Cx5.
One of the things that's so unique about my approach is how much of the actual sculpting I do with a marching band accompanying me. It's very helpful, I've found, to have a steady beat to sculpt, which was start that again.
And talk with your hands. The way that I do. Not that, not jazz hands.
How am I with the hands? More hands?
Yeah, more hands, please.